வணக்கம். இந்த வீடியோல நிறைய விஷயங்கள் பத்தி பார்க்க போறோம். கவனிங்க. So common ion effect, buffer solution, buffer action, buffer capacity னா buffer index னா என்ன, அதுக்கு அப்புறம் Henderson Hasselbalch equation அப்படினு சொல்லிட்டு நிறைய விஷயங்கள் பார்க்க போறோம். Listen carefully. Right? Okay. Common ion effect. What is common ion effect? Consider a weak acid or a weak base. Any weak substance. For example, consider acetic acid. So weak substance partially dissociates layer. So it will form acetate ion and H plus ion. Okay. Weak acid, its conjugate base will be a strong one. Okay. Right. Suppose if I am adding sodium acetate to this compound, it is a strong salt. Salt of the weak acid is very strong one. So it completely dissociates and give acetate ions and Na plus sodium ion. Now, by Lee-Chatelain principle, when this equilibrium is affected, how it is affected? The concentration of one product is increased. By adding sodium acetate, concentration of this acetate is increased. So what happens to this equilibrium? By Lee-Chatelain principle, it goes to the backward side. It goes to the backward direction. So the common ion effect is that the degree of dissociation, the forward reaction is suppressed. Now listen carefully. Dissociation is suppressed. How it is suppressed? By adding a common ion. By adding a common ion. This effect is called as common ion effect. So the dissociation of weak acid is suppressed by adding a common ion, which is called as common ion effect. Okay, then, sir, what is a buffer solution? See here, consider a solution, normal solution. A normal solution, it may be salt in water, sugar in water, and HCl in water, anything it may be. It will have a pH value. It will have a pH value. If I am adding acid, what happens to the pH value? pH enna agum? Very good. If I am adding acid, pH decreases. pH decreases. Okay. If I am adding base, suppose if I am adding base, what happens to the pH value? pH increases. pH increases. Very good. Why? We have discussed those things earlier itself, in previous videos itself, right? So, but a buffer solution is one. A buffer solution is one in which when we are adding small amount of acid or base, the pH will not change. The pH will not change. Those solutions are called as buffer solution. So, buffer solution, they resist pH change upon addition of small amount of acid or base. So they resist pH change when they are mixed with small amount of acid or base. So which solution will act as buffer solution, sir? Very simple. Examples of buffer solution: a weak acid with its salt, right? Similarly, a weak base with its salt, they may act as buffer solution. Right, a weak acid may combine with its conjugate strong salt. It is called as acidic buffer. Similarly, if a weak base is present with its conjugate strong salt, it is called as basic buffer. There are two types of buffer: acidic buffer and basic buffer. Example: weak acid, acetic acid, and its salt, sodium acetate. Yeah, the same one which we have discussed here. Weak base, example: ammonium hydroxide, and its salt, ammonium chloride. These are the best examples by which you can easily understand. So, what is buffer solution? Sir, when we are adding small amount of acid or base, the pH of the solution will not change. Those solutions are called buffer solutions. Very good. Now, how a solution by adding acid or base maintains the pH? By how it is maintaining the pH constant, we are going to discuss here. See here, this is already discussed. This is the common ion effect, and also it is an example for acidic buffer. Okay. Now we are going to discuss about the buffer action. How this is maintaining the pH when we are adding acid or base. See here, if acid is added, what will increase? Acid will produce what ions? H plus ions are produced. Right, very good. These H plus ions are combining with acetate ions present in the buffer. and it will form neutral molecule, neutral acetic acid molecule. Okay, so the H plus ions are neutralized, so the pH remains constant. So the pH remains, H plus ions are neutralized. This is the main thing. How it is neutralized? Sir, this is the reaction for neutralization. So the pH remains constant. So pH remains constant. Very good. Then if base is added means what increases? OH minus ions are added. So these OH minus ion combine with H plus and it will be forming water molecule, neutral water molecule. At the same time, since H plus are consumed, this reaction will proceed now in forward direction. That means acetic acid will dissociate and gives acetate ions plus H plus ions. So these two reactions will happen. Sir, what is the net reaction? What is the net reaction? Just strike out the same things on the opposite side. So the net reaction is OH minus plus CH3COOH gives CH3COO minus plus H2O. See, these two are on the left side and these two are on the right side. So how a buffer solution resists pH? That is a simple question. Sir, if acid is added, the H plus ions are neutralized by acetic acid to form neutral molecules, so the pH will not change. If base is added, okay, sir, the base OH minus ions are consumed by this H plus to form neutral molecule. In order to maintain equilibrium, some amount of acetic acid will dissociate. So this is the net reaction happening and the OH minus ions are neutralized. So what is the main thing here is that upon addition of small amount of acid or addition of small amount of base, buffer, the pH of the buffer will not change. Okay. Right. Buffer capacity or buffer index. So the buffering ability of a buffer is explained by means of buffer capacity, and it is measured by means of buffer index beta. Right. What is meant by buffer index, sir? It is nothing but the numerator. It is the number of gram equivalents of acid or base that is required to change the denominator. Difference in pH is 1. See here, if there is a buffer with a pH, so how much amount of acid can be added to decrease its pH by 1, or how much gram equivalents of base can be added to increase its pH by 1. Okay, so that is called as buffer capacity. So the number of gram equivalents of acid or base required to change the pH denominator 1, to change the pH by 1 is called as buffer index. Okay, now we are going to deal the main thing, Henderson Hasselbalch equation. See here, it is very important. Okay, I have already mentioned you that a buffer solution will have some pH value. Let its pH be X. Let its pH be X. If you add acid, the pH value X will not change. If you add small amount of base, the pH value X will not change. Okay. Sir, how can I develop? I know how to develop a buffer. Sir, by adding weak acid and its salt, I can develop the acidic buffer. But I need an acidic buffer with a pH X. How can I develop, or how can I create that buffer? For that, we need the Henderson-Hasselbalch equation. Okay. Just I have made a small correction from the previous equation. So previously here I have mentioned H plus. Now I have mentioned it as H3O plus. It is not at all a matter of concern, right? What is Henderson-Hasselbalch equation? See here, the concentration of H3O plus here. The concentration of H3O plus here, it is directly proportional to Ka. Ka is nothing but the dissociation constant of the acid, and also concentration of this acid. If this acid is having more concentration, then more dissociation will be there and more H plus will be there, numerator, and inversely proportional to the concentration of this salt. Why, sir? If salt is present more forward reaction will occur here, and the first reaction will go to the backward side. That is, H3O plus will decrease if this increase. If this salt increase, H3O plus will decrease. So I think you are clear with this equation now, right? Then consider the first two again, right? Okay, in generalized form, when they are asking this Henderson-Hasselbalch equation in your exam, you have to write in generalized form. So I am taking like this, HA. It is a weak acid. So it dissociates partially, H plus plus A minus. Right. Now for this equation I can write the equilibrium constant or dissociation constant of the acid. So concentration of H plus into concentration of A minus by concentration of HA. Okay. Now I am adding the strong salt. So this undergoes forward reaction only. So this will happen. Now what happens to this first reaction? What happens to the first reaction? Sure, sir, common ion is present. So the first reaction will go to the back. First reaction will go to the backward direction. Okay. Now see here. Now this A minus present in the solution is completely due to the salt. So I can write the value of A minus as the concentration of salt. Similarly, I can write the value of HA as the concentration of acid, because when I am adding this, the first reaction is reversed. So totally all the acid molecules are present now as HA. Simply saying, in this buffer only these three substances exist. Only these three substances exist, because on adding this it will completely dissociate. First reaction will go to the reverse direction. So I am going to use these terms in this equation. I am going to use these terms in this equation. See here, Ka is equal to concentration of, I can write it as H3O plus because it is mentioned as H3O plus. Not issue, not a big matter of concern. So concentration of H3O plus into concentration of A minus can be replaced as salt by HA can be replaced as concentration of acid. Right. I am going to derive the value for H3O plus concentration. So keep it on one side and take the others to other side. So Ka into concentration of acid by concentration of salt will be the form. Now multiply by minus logarithm on both sides. Apply minus logarithm on both sides. So the left side will become minus log of H3O plus is equal to minus log Ka minus log concentration of acid by concentration of salt. Concentration of acid by concentration of salt. Okay. See here, this can be replaced as pH, which we have already studied. So pH is equal to minus log H3O plus. Similarly, this can be replaced by pKa, and minus can be reversed plus F. When means salt goes to the numerator and acid comes to the denominator. So log of concentration of salt by concentration of acid. So this is the Henderson equation which is needed for us to develop the buffer solution of desired pH. So look here, we can develop a buffer solution of whatever the pH we need. Okay, how we have to develop, sir? This is the term. So suppose if I need a buffer solution of pH 5, substitute here 5. Substitute the value of, so pH 5, okay, substitute the value of Ka for that acid. So each and every acid has a specific Ka value. Substitute the value here and find out pKa. So take this value to the other side. By adjusting these two, so we can develop the buffer of desired pH 5. Okay. Similarly, this is for acidic buffer. For basic buffers, we can develop POH. The same Henderson Hasselbalch equation can be written as POH is equal to pKb. For A, you are using B base plus log concentration of salt by concentration of base. Instead of acid, we have to use base. So this is the equation for Henderson equation of basic buffer. Okay. I think you are all very well clear